Hello and welcome to Algebra 1, Lesson 13. In this video, we're going to learn about linear equations in two variables. All right, so the last chapter was all about linear equations in one variable, and we also talked about linear inequalities in one variable, but now we're going to move on and talk about linear equations in two variables, okay, in two variables. So a linear equation in two variables is an equation of the form ax plus by equals c, where a, which is the coefficient of x, b, which is the coefficient of y, and c, which is a constant term, are real numbers. And again, I know I haven't given you an official definition for, what a real number is, but it's at this point any number you can think of. So I could put fractions there, decimals, negatives, doesn't really matter. Anything you could think of at this point could go in there. But there is a restriction. We say that a and b are not both 0. So these are the coefficients for our variables. So we can't have both of them 0 at the same time. I could have one of them be 0, but the other one could not be 0. So here are some examples. We have 4x plus 3y equals 7. So you see you have two variables here. You have an x variable and a y variable. We have negative 2x minus 4y equals 13. Again, two variables here. You have an x variable and a y variable. And then 1/4 x plus 18y equals 12. Again, x and then y. So when we worked with a linear equation in one variable, we generally had exactly one solution. And I know we talked about a special case scenario where that's not going to be true, but in general, we had one solution. So if I looked at something like 2x equals 8, we already know how to solve this. We divide both sides of the equation by 2, which is the coefficient of x. This cancels with this, and I just have x equals 8 divided by 2 is 4. So there's exactly one solution here. There's only one number that when plugged in for x gives us a true statement. And what we're going to see when we start working with linear equations in two variables is that there's an infinite number of x, y combinations that are going to make the equation true. So let's talk a little bit about how to write a solution for a linear equation in two variables. So we typically write our x and y values using what is known as an ordered pair. So you might want to write that down because it's an extremely important vocabulary term. An ordered pair looks like this. You have an x, comma, a y. So all the way on the left is always your x value, And then on the right is always your y value. These are not interchanged, ever. It's always the x value, comma, the y value. So in other words, if I give you an ordered pair, 3, comma, negative 1, 3 is your x value, and negative 1 is your y value. So again, the x value is on the left, the y value is on the right. All right, so now let me show you how to check an ordered pair and see if it's a solution to a linear equation in two variables. So we have this 4x plus 2y equals 12, and we want to check the ordered pair 3, comma, 0. So the important thing to remember is that, again, the left value is the x value, and the right value is the y value. Very, very important you understand that. So just like we did with a linear equation in one variable, so for example, if I have 2x equals 8, like we had earlier, and I said x is equal to 4. All right, this was the solution. I plug a 4 in for x, so 2 times 4 equals 8, and we see that the left and the right side are equal. 8 equals 8. That's how I know that x equals 4 is the solution. Well, it's the same here. All I'm going to do is take each number and plug it in for its respective variable. So 3 will get plugged in for x because it represents the x value. 0 will get plugged in for y because it represents the y value. So I would have 4 times, again, I have an x here. This is my x value. So I'm going to put a 3 plus 2 times 0 is my y value. So I'm putting in a 0 for y equals 12. Very, very simple. I'm just plugging in just like I did with a linear equation in one variable, right? If I had the solution there, I plugged in for x. I found out if the left and the right side were equal. I'm doing the same thing here. I'm just including another variable. I now have 2 of them. So 4 times 3 is 12. plus 2 times 0 is 0. So I can put plus 0, or I could just leave it as 12. And this is supposed to equal 12, and it does. We get the same value on the left and the right side. And so we can say this ordered pair, 3, 0, is a solution for our equation. All right, let's take a look at some problems now. We have negative 4x minus y equals 16. And we're going to check each ordered pair and see if it's a solution to the equation. So we have our first ordered pair, which is negative 5, 4. Again, the left value is the x value. The x value. The right value is the y value. So we have negative 4x. So instead of x, I'm going to plug in a negative 5. Right? This is what I'm plugging in for x. So negative 4 times negative 5 minus, now I have a y. And I'm plugging in a 4 for y. Okay, because that's my y value. So minus 4, and this equals 16. So negative 4 times negative 5 is 20. Then minus 4 equals 16. 20 minus 4 is 16, so you get 16 equals 16. So yes, this ordered pair negative 5, 4 is a solution. So I'm just going to put a check mark here. All right, the next ordered pair we're going to look at is 0, 2. And again, we have our left value as our x value. Our right value is the y value. And that's not going to change. Okay, you just memorize that. The one on the left is the x. The one on the right is the y. So we have negative 4 times our x value is 0. So I'm going to plug in a 0 there. Minus our y value is 2 equals 16. Negative 4 times 0 is 0. So then minus 2 equals 16. So we get negative 2 equals 16, and that's not true. This is false. So this does not work as a solution. So this doesn't work. All right, let's try the ordered pair 0.5, negative 18. So again, the left value is the x value, and the right value is the y value. So we're just going to plug in. We'll have negative 4 times x, and again, x is going to be 0.5, or that's 1/2, whatever you want to put in there, minus, for y, we have negative 18. And this is very important. When you're plugging in for something, this is negative 18 that I'm plugging in here for y. There's a minus sign already out in front. So this stays there, and then you put minus 18, or negative 18. And minus a negative is plus a positive. So I can write minus a negative 18, or I could simplify that and put plus positive 18, which I'm going to do in the next step. So equals 16. So what's negative 4 times 0.5? Again, you could do that using negative 4 times 1/2 and kind of mentally say, okay, well, negative 4 times 1/2 is negative 2. So this is negative 2. Minus the negative 18 is plus 18 equals 16. And so, yeah, this is going to be true. Negative 2 plus 18 is 16. 16 does equal 16. Same value on each side of the equation. And so we're going to check mark this and say, yes, it is a solution to the equation. And one thing this would immediately draw your attention to is the fact that, again, we can have more than one ordered pair that works as a solution to a linear equation in two variables. When we worked with a linear equation in one variable, generally speaking, we're going to have exactly one value for our variable that makes the equation true. Here, we have multiple ordered pairs or multiple solutions here that work. And in fact, you're going to find that with a linear equation in two variables, there's an infinite number of ordered pair solutions. All right, so now we're going to look at negative 7x minus 3y equals 42. And we want to check the ordered pair 3, 8, the ordered pair negative 9, 7, and the ordered pair 2, negative 5. So let's start with this ordered pair 3, 8. So this is your x value. This is your y value. And let's do some plugging in. So we have negative 7 times, for my x value, I'm putting in a 3, minus 3 times, for my y value, I'm putting in an 8. And this should be equal to 42. Negative 7 times 3 is negative 21. Negative 3 times 8 is negative 24. So minus 24 equals 42. Negative 21 minus 24 is negative 45. And this is not equal to 42. This is false. So this does not work out as a solution. To make this a little quicker, I'm just gonna erase this part, which is where we plugged in. Right? The rest of the equation is always going to be the same. You'll have your negative 7 times your spot for x, then minus 3 times your spot for y, then equals 42. So I'm just going to erase those parts. Now I'm going to be plugging in a negative 9 for x. This is my x value. So negative 9 goes here, right? We have negative 7 times x, so negative 7 times negative 9. And I'm going to plug in a 7 for y. Again, here's my y value. I have negative 3 times y, so I'm plugging in a 7 for y, so I go negative 3 times 7. So negative 7 times negative 9 minus 3 times 7 equals 42. Negative 7 times negative 9 is 63. Minus 3 times 7 is 21. This should equal 42. And in fact, it does. 63 minus 21 is 42. So you get 42 equals 42. So that checks out. And so we can say that negative 9 comma 7, this ordered pair, is a solution. All right, let's do one more. And again, I'm just going to erase the part where we plug in. And I have a 2 that's going to represent my x value, and a negative 5 that's going to represent my y value now. So where's x? We have negative 7 times x, negative 7 times this right here. So 2, which is my value for x, is going to go in right here. And then my y value of negative 5 is going to go in right here. Right? Again, I'm just plugging it in right there next to negative 3. So I have negative 7 times 2 minus 3 times negative 5 equals 42. Negative 7 times 2 is negative 14. Negative 3 times negative 5 is 15, so plus 15, equals 42. Negative 14 plus 15 is 1, and 1 is not equal to 42. This is false. So this doesn't work out. So for these type of equations, we can pick a value for x and solve for y, or vice versa. So I could pick a value for y and solve for x. And this is going to be a very important skill that we're going to use throughout this chapter. All right, so let's start out by looking at this equation. We have x minus 3y equals 15. Now, I'm given some values for x and for y here. This is a table of values. And what's going to happen is, okay, for example, here, I'm given a value of 0. So I would plug 0 in for y, and I would solve for x. So let me show you what that looks like. So we have x minus 3 times y. I have a given value of 0 for y, so I'm going to plug that in, equals 15. So then if I simplify this, I'd have x equals 15, right? 3 times 0 is just 0. If I'm subtracting away 0, it's like I just have x. All right, so x equals 15. So that's the value for x that makes this equation true when y is 0. So I can go ahead and just fill in the missing value and put, okay, this is 15. So the ordered pair, 15 comma 0 is a solution to this equation, right? 15 is my value for x, the value on the left. 0 is my value for y, the value on the right. All right, so now I'm given an x value of 0. So I'm going to plug a 0 in for x. So instead of x minus 3y equals 15, I'm going to put 0 minus 3y equals 15. Really, the 0 out in front doesn't do anything, so I can just get rid of it. And I'm left with negative 3y equals 15. So to solve for y, we already know how to do that. I want to isolate y, so I just divide both sides of the equation by negative 3. Nothing we haven't done before. This will cancel with this, and I'll just have y, and then it equals 15 divided by negative 3 is negative 5. So if x is 0, y equals negative 5. Let me kind of put that in a different color so it stands out. So let's put negative 5 here. So again, this is another ordered pair that works as a solution to this equation. We can put the ordered pair 0, comma, negative 5 is a solution. Again, where 0 is the x value and negative 5 is the y value. All right, now we're given a y value of negative 2, and we want to find the missing x value. So we have x minus, I'm plugging in a negative 2 for y, so I'm going to have 3 times negative 2 equals 15. So negative 3 times negative 2 is 6, so I would really have x plus 6 equals 15. And I want to solve for x. And again, we know how to do that. If we want x by itself, I just need to subtract 6 away from each side of the equation. So that's going to cancel. I'm going to have x is equal to 15 minus 6 is 9. So x equals 9. So let's put that over here. And I'm going to remember to use a different color this time. And I'm going to put 9 there. So that's another ordered pair that works as a solution. So we can say the ordered pair 9, comma, negative 2. Again, works as a solution for this equation. Now let's do one more. We're given an x value of negative 7. So I'd plug a negative 7 in for x. So then minus 3y equals 15. Want y by itself, so I'm going to add 7 to each side of the equation. That's gone. I'll have negative 3y is equal to 22. If I divide both sides of the equation by negative 3, so that y can be by itself, this will cancel with this, and I'll have y equals negative 22 thirds. And there's nothing to do to simplify that. 22 is 11 times 2. I can't really cancel anything with the 3. We'll write that over here as negative 22 thirds. And again, that's another ordered pair that's a solution to our equation. Let's just write that real quick. It would be negative 7, comma, negative 22 thirds. And I can go through and keep generating as many ordered pair solutions as I want. I can pick a value for x, doesn't matter what it is. I can plug it in, and I can solve for y. So that would give me the x value that I picked and the y value that I solved for. Put those two together, that gives me an ordered pair that's a solution. I could do the opposite thing. I could pick a value for y and solve for x. All right, let's take a look at another example of this. So we have 2x plus 3y equals negative 24. So we're given an x value of 3. We want to solve for the unknown y value. So if x equals 3 here, I would have 2 times, I'm plugging in a 3 for x, plus 3y equals negative 24. So 2 times 3 is 6. So I would have 6 plus 3y equals negative 24. Subtract 6 away from each side. I'd have 3y equals negative 30. And then I would divide both sides by 3, right, in order to isolate the variable y. This cancels with this. Negative 30 divided by 3 is negative 10. So you get y equals negative 10. So I can put a negative 10 there. And so my ordered pair would be 3 for my x value, comma, negative 10 for my y value. Now let's look at, we're given a y value of 8. We want to find the unknown x value. So we have 2x plus 3. We're plugging in an 8 for y. This equals negative 24. So we have 2x plus 3 times 8 is 24 equals negative 24. We subtract 24 away from each side. That's going to cancel. And I'm going to have 2x is equal to negative 24 minus 24 is negative 48. So now I can divide both sides of the equation by 2 in order to isolate x. This will cancel with this. And I'd have x is equal to negative 48 divided by 2 is negative 24. So we can come back up here and say that the missing value here is negative 24. Right, this would be another ordered pair solution. Negative 24 for the x value, 8 for the y value. All right, for the next one, I have an x value of 4, and I want to find the unknown y value. So I'll have 2 times, I have x, I'm plugging in a 4 for x, plus 3y equals negative 24. So 2 times 4 is 8, so we have 8 plus 3y equals negative 24. We subtract 8 away from each side. We'll have 3y is equal to negative 32. Divide both sides of the equation by 3 so that I can isolate y. And I'll have y is equal to negative 32 thirds. And there's nothing I can do to simplify that. If I think about 32, that's 2 to the 5th power, right? I can't cancel any of those factors of 2 with this 3 here. So this is simplified. So our missing value for y would be negative 32 thirds. All right, so my ordered pair solution there would be 4, comma, negative 32 thirds. All right, for the last one we're going to look at, we're given a y value of negative 10. So we have 2x plus 3 times, I'm plugging in a negative 10 for y, is equal to negative 24. So we then would have 2x, 3 times negative 10 is negative 30, so minus 30, equals negative 24. I'm going to add 30 to both sides of the equation. That's going to cancel. I'll have 2x is equal to negative 24 plus 30 is going to be 6. And that can divide both sides of the equation by 2 to isolate that variable x. So divide by 2, and I'm going to get that x is equal to 3. All right, so I'm going to write that x is 3. It's our unknown value. And again, I'll write this as an ordered pair, just so you get a little practice doing it and seeing it. So the ordered pair would be 3 for the x value, comma, -10 for the y value. And again, you can pick any value you want for x and solve for y, or you could pick any value you want for y and solve for x. So for example, let's say that I wanted to pick, I don't know, a value of 0 for x. I could say, what is the resulting y value that makes the equation true when x is 0? So I just plug in a 0 for x, so I'd have 2 times 0 plus 3y equals -24. So 2 times 0 is 0, so I just have 3y equals -24. And this is just a linear equation in one variable. We know how to solve this already. We're just trying to isolate y at this point. So I divide both sides of the equation by 3, and I get y equals -8. Right? So if x is 0, y is -8. Right? This is the ordered pair, 0, -8, and it's a solution to this equation, 2x plus 3y equals -24. And again, if you want to go back and prove that to yourself, plug both of them in at the same time. So plug in a 0 for x, 2 times 0, plus 3 times, plug in a -8 for y, so 3 times -8 equals -24. 2 times 0 is 0, so this is gone. So we just have 3 times -8, that's -24, and that does equal -24. You can see that this ordered pair, again, 0, -8, is a solution for this equation.